Today I'm talking about LeetCode problem 1367, linked list in a binary tree. So what this problem asks you to do, it says you're going to be given a binary tree called root and a linked list called head. And what they want you to do is return true if all of the elements in your linked list occur in a downward path of the binary tree. So here you're given a linked list with the elements 4, 2, 8, and you should return true because there is a downward path of your binary tree with those elements 4, 2, 8. And so it doesn't need to be the first elements in your binary tree. This sequence just needs to occur somewhere within a downward path. And the constraints, it says, I don't know, the constraints don't seem that important, that the value on the node is going to be between 1 and 100, who cares, and that there will be up to 2,500 nodes. I suppose that is a bit more important for testing scalability. When I was working on this problem, though, I actually found it hard to just create the linked lists and binary trees. It's a bit cumbersome to create those in order to get some test cases to work with. So I wound up just taking a best effort and then submitting it to see if I solved it or not. So the solution I wound up with is a recursive solution. And it starts with this function here, the is subpath. And here I take this function to be essentially solving the problem given by the problem statement. So it's saying from this tree node, or from this binary tree, are any of the descendants or this node itself the path described in list node? And so here I have two kind of base cases. One would be that there are no values left. So our linked list has been entirely exhausted, and so it's just an empty set. In which case, if that were true, yeah, this is a subpath. Like there's an empty subpath here, or anything is an empty subpath. And the other possibility is that node, meaning the binary tree node that I'm currently at, or the binary tree node, is none. And if that's the case, if the binary tree node is none, and we still have values because we didn't hit this condition, so we still have some values left, we know for sure that we aren't going to complete our values list in a downward path if we're already hitting a none. So those are the two base cases. And then the recursive case basically has 3 branches. So I'll talk about this first branch in a second, but the other 2 branches are really just saying, okay, let's do the is subpath of my left child and my right child. So I asked, is the root a subpath? Maybe it is, maybe it isn't. And then either way, is my left child a subpath? Is my right child a subpath? And so you can see how that logic will continue on. It'll try left and right child of the root node. So here it's trying the left child, it's going to try the left and right child here. When it tries the left child, it's going to hit this condition that my node is none, and it's just going to return false. And then here it's going to check if this is a subpath, and so on. I'll explain more about that when I talk about this primary recursive case, which is a similar function, subpath, which is just going to say, is the node I'm currently at, does that map out this values list? So just the difference between subpath, this function, and is subpath is saying, does any descendant have the path? Whereas subpath is just saying, do you have the path? So the entire thing here says, does the current node I'm on, does that have the path described by the values list? Or does my right-hand child, or does my left-hand child? I said that backwards. Or does my left-hand child, or does my right-hand child? And so to do this subpath function, we again have the same 2 base cases. if the values list is none, then true. If the node is none, then false. And otherwise we say, okay, if the top value in my linked list is not equal to the value in my node, then I'm going to return out false. And otherwise, I'm going to recursively call, or I'm going to return the recursive case, which is the next value and the left-hand side of the linked list, or the next value and the right-hand side of the linked list. So let me try to just illustrate that real quick. So like here we have 1, 4, I guess they don't really need to be in circles, 7, and we'll just say 2. And say we're looking for a linked list that is 4 and 2. So we start with our root here, and we say, okay, this is not null, so we can check it for its value. This is not null, and the list we're checking for isn't null. So okay, we can check it for the value. No, these two don't match. Okay, so we're going to return the OR of subpath of your left child and subpath of your right child. So right we won't explore, but you know, as a spoiler, it doesn't work out. So the OR would be left path or false or right path. When we explore the left-hand child, you know, we pick up a node. This isn't null, this isn't null. So our subpath function would say, okay, do these two match? They do. Okay, so what we're going to return when these two match is the OR of the subpath of the left-hand side and the right-hand side with our linked list values val.next. So we'll just explore the subpath of the left-hand side, which will work out and succeed and return true up our recursive chain, or the right-hand side, which would return false. And so because all of these recursive calls are just ORed together, that's how it works, that if any one of them succeeds, then if any one of them hits a true condition, then the entire statement will evaluate to true. And yeah, that'll get us to our solution recursively. It's not super fast. Actually, when I looked at the other solutions, it's highly similar to at least the other solutions I saw in the discussion section. I think most people solve this recursively. There's just something about a binary tree that kind of calls out for a recursive solution. It's at least easy to do that way. But yep, this is the solution to LeetCode problem. Let's see, what is it? 1367. Yeah, I'm going to try to keep solving a LeetCode problem a day or something like that. And when I do solve them, I'll just record a quick video to discuss my solution. So if you're interested in that, subscribe, click the like button. Thanks for your time.